When encountering a situation where voltage drop calculations necessitate using a #6 cable on a 20 amp circuit, several methods can be employed to safely and effectively connect the larger gauge wire to the circuit breaker. Firstly, adapting the circuit breaker to accept the #6 cable can be achieved using a lug. This involves attaching a crimp or solder lug to the end of the #6 cable to reduce its diameter, allowing it to fit securely into the circuit breaker screw terminal. Secondly, an alternative method is to pigtail with a smaller wire. This involves running a short length of smaller gauge wire, such as #14 or #12, from the circuit breaker to a terminal block or junction box. The #6 cable is then connected to this terminal block or junction box, effectively bridging the size difference. When implementing these methods, several crucial factors must be considered. The neutral and ground wires within the circuit must also be sized appropriately, taking into account the voltage drop calculation to ensure consistent and safe operation. Furthermore, the #6 cable typically requires a larger conduit than what is commonly used for 20 amp circuits. It is essential to verify that the conduit being used is adequately rated for the size of the cable and the number of conductors it will contain. Code compliance is paramount. Always verify whether the local electrical code permits the use of a #6 cable for a 20 amp circuit, as regulations may vary depending on the location. Several recommended wiring practices should be followed to ensure a safe and reliable electrical connection. All connections must be properly tightened to prevent loose wires, which can lead to potential hazards such as arcing and overheating. Applying anti-oxide paste to the terminals helps prevent corrosion, ensuring a good electrical contact that will maintain conductivity over time. To prevent sagging or damage, use cable clamps or straps to securely support the cables. Finally, clearly label the wires at both ends to facilitate future maintenance and troubleshooting, making it easier to identify and work with the circuit in the future. When dealing with electrical work, safety is of utmost importance. Always ensure that the power is disconnected before working on any electrical components. Employing proper personal protective equipment, such as insulated gloves and safety glasses, is crucial for preventing electrical shock and other injuries. Thorough understanding of electrical codes and regulations is essential for ensuring that all work is performed safely and in compliance with legal requirements. If unsure about any aspect of the installation, consulting a qualified electrician is always recommended. An electrician can provide expert guidance and ensure that the installation is performed safely and correctly. The correct wire size for an electrical circuit depends on several factors, including the amperage of the circuit, the length of the wire run, and the allowable voltage drop. Using a wire that is too small can lead to overheating, voltage drop, and potentially fire hazards. National Electrical Code, or NEC, Table 310.15b16 provides guidance on the allowable ampacities of insulated conductors rated up to and including 2000 volts, based on the insulation type and temperature rating of the wire. This table is essential for determining the appropriate wire size for a given circuit. Voltage drop is the decrease in voltage that occurs along the length of a wire due to its resistance. Excessive voltage drop can cause appliances and equipment to operate inefficiently or not at all. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Calculating voltage drop involves using Ohm's law and considering the wire's resistance, length, and the current flowing through it. The formula for voltage drop is voltage drop equals current times resistance. To calculate the voltage drop, the resistance of the wire must be determined. The resistance of a wire depends on its material, length, and cross-sectional area. Wire manufacturers provide tables that list the resistance per unit length for different wire sizes. Once the resistance is known, the voltage drop can be calculated using the formula mentioned earlier. If the calculated voltage drop exceeds the allowable limit, a larger wire size should be used to reduce the resistance and voltage drop. For example, consider a 20 amp circuit with a wire run of 100 feet. The allowable voltage drop is 3%, which is 3.6 volts for a 120 volt circuit. Using #12 copper wire, the voltage drop is calculated to be approximately 7 volts, which exceeds the allowable limit. In this case, a larger wire size, such as #10 copper wire, should be used to reduce the voltage drop to within the acceptable range. The NEC provides guidelines for the number of conductors that can be installed in a conduit. The fill rate, or the percentage of the conduit's cross-sectional area occupied by the conductors, should not exceed certain limits. This is to ensure adequate space for heat dissipation and to prevent damage to the conductors during installation. NEC Chapter 9, Table 1 specifies the maximum percentage fill for different types of conduit and numbers of conductors. Exceeding the conduit fill limits can lead to overheating, insulation damage, and potentially fire hazards. When pulling wires through a conduit, it is essential to use pulling lubricant to reduce friction and prevent damage to the insulation. The lubricant should be compatible with the wire insulation and the conduit material. Proper pulling techniques, such as using a pulling eye and a smooth, continuous pulling motion, can also help prevent damage to the wires. Making proper electrical connections is crucial for ensuring a safe and reliable electrical system. All connections should be made in approved junction boxes or enclosures. Wire connectors, such as wire nuts or terminal blocks, should be used to join wires together securely. The connectors should be sized appropriately for the wire gauge and the number of conductors. All connections should be tightened properly to prevent loose wires, which can lead to overheating and arcing. Grounding is an essential safety measure that helps protect against electrical shock. All electrical equipment and appliances should be properly grounded. The grounding system provides a low resistance path for fault current to flow back to the source, causing the circuit breaker to trip and energize the circuit. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors. The grounding electrode system, which connects the electrical system to the earth, should be installed in accordance with the NEC requirements. Regular inspections and maintenance of electrical systems are essential for ensuring continued safety and reliability. Visual inspections should be performed to check for any signs of damage, such as cracked insulation, loose connections, or corroded terminals. Electrical testing, such as insulation resistance testing and ground impedance testing, should be performed periodically to identify potential problems before they become hazardous. Any identified issues should be addressed promptly to prevent electrical hazards and ensure the proper functioning of the electrical system. When working on electrical systems, always follow safe work practices. To energize the circuit before working on any electrical components. Use lockout/tagout procedures to prevent the circuit from being accidentally re-energized while work is in progress. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Use insulated tools to prevent electrical shock. Work in a well-lit and dry environment. Avoid working alone, and always have someone nearby who can provide assistance in case of an emergency. If unsure about any aspect of the electrical work, consult a qualified electrician. Continuing education and training are essential for staying up to date on the latest electrical codes, technologies, and safety practices. The electrical industry is constantly evolving, and it is important to keep abreast of these changes to ensure that electrical work is performed safely and in compliance with current regulations. Attend seminars, workshops, and online courses to enhance knowledge and skills. Obtain certifications from recognized organizations to demonstrate competence in electrical work. Stay informed about changes to the NEC and other relevant standards. Share knowledge and experience with colleagues to promote a culture of safety and continuous improvement. Adapting a circuit breaker to accept a #6 cable on a 20-amp circuit requires careful consideration of several factors, including the methods used to connect the larger gauge wire, the sizing of neutral and ground wires, the conduit size, and code compliance. Following recommended wiring practices and adhering to safe work practices are essential for ensuring a safe and reliable electrical system. Regular inspections and maintenance, along with continuing education and training, are crucial for maintaining electrical safety and preventing electrical hazards. In some cases, the use of a larger wire, such as a #6, on a 20-amp circuit might stem from specific application needs. For example, in long circuit runs, voltage drop becomes a significant concern. Voltage drop refers to the reduction in voltage along the conductor's length due to the wire's inherent resistance. Excessive voltage drop can lead to equipment malfunction, reduced efficiency, and potential overheating. To mitigate voltage drop in long runs, a larger wire gauge is employed to reduce the resistance per unit length. Even though the circuit is protected by a 20-amp breaker, which would typically dictate a smaller wire gauge under normal circumstances, the overriding concern for voltage drop necessitates the larger conductor. Another scenario where a larger wire might be used is in environments with high ambient temperatures. Higher temperatures increase the resistance of conductors, further exacerbating voltage drop. Additionally, high temperatures can degrade the insulation of the wire, reducing its lifespan and increasing the risk of failure. To counteract these effects, a larger wire with a higher temperature rating is selected. The increased cross-sectional area of the larger wire helps to dissipate heat more effectively, while the high temperature rating of the insulation ensures its integrity in elevated temperature conditions. In some industrial or commercial settings, specific equipment may require a dedicated circuit with a larger wire gauge than the circuit's ampacity would normally suggest. This might be due to the equipment's sensitivity to voltage fluctuations or the need for a more robust and reliable power supply. In such cases, the equipment manufacturer's specifications should be consulted to determine the appropriate wire size. It's also essential to consider the dirting factors that may apply to the wire's ampacity. Dirting refers to reducing the allowable current carrying capacity of a wire under certain conditions. Factors that can necessitate dirting include high ambient temperatures, multiple conductors in a conduit, and the presence of insulation. The NEC provides tables and guidelines for dirting wire ampacity based on these factors. When dirting is required, a larger wire gauge may be necessary to compensate for the reduced ampacity and ensure that the circuit can safely handle the intended load. In any electrical installation, it is crucial to adhere to the applicable electrical codes and regulations. These codes are designed to ensure the safety of electrical systems and protect against hazards such as fire and electrical shock. Before installing any electrical wiring, it is essential to consult the local electrical code to determine the specific requirements for wire size, conduit fill, grounding, and other aspects of the installation. The electrical codes vary depending on the location, so it is important to verify the applicable code in the specific area where the work is being performed. In situations where a larger wire is used on a 20-amp circuit, proper labeling and documentation are essential. The circuit breaker panel should be clearly labeled to indicate the wire size used on the circuit. This helps prevent confusion and ensures that future electricians or technicians are aware of the unusual wiring configuration. Additionally, it is helpful to document the reason for using the larger wire, such as voltage drop or high ambient temperature. This documentation can be kept with the electrical panel or in a separate record book. Proper documentation can help prevent future problems and ensure that the electrical system is maintained safely and effectively. When connecting a larger wire to a 20-amp circuit breaker, it is essential to use appropriate connectors and terminals. The circuit breaker terminals are typically designed for a specific range of wire sizes. If the wire is too large to fit directly into the terminal, an adapter or reducer may be necessary. Several types of adapters are available, such as crimp-on lugs and terminal blocks. These adapters allow the larger wire to be securely connected to the circuit breaker terminal. It is important to select adapters that are rated for the wire size and the ampacity of the circuit. Additionally, the adapters should be installed according to the manufacturer's instructions. In some cases, it may be necessary to replace the circuit breaker with one that is designed for larger wire sizes. Circuit breakers with larger terminals are available from various manufacturers. When selecting a replacement circuit breaker, it is important to ensure that it is compatible with the existing electrical panel and that it meets all applicable safety standards. The replacement circuit breaker should be installed by a qualified electrician. When working with electrical wiring, it is essential to use proper tools and equipment. Wire strippers, crimpers, and other specialized tools are designed to make electrical connections safely and effectively. It is important to use the correct tool for each task and to follow the manufacturer's instructions. Additionally, it is essential to inspect tools regularly to ensure that they are in good working condition. Damaged or worn tools should be replaced immediately. Using the wrong tools or using tools improperly can lead to damaged wiring, loose connections, and potential safety hazards. Electrical testing is an important part of any electrical installation. Before energizing a circuit, it is essential to test the wiring to ensure that it is properly installed and that there are no faults. Several types of electrical tests can be performed, such as continuity testing, insulation resistance testing, and voltage testing. Continuity testing verifies that the wires are connected properly and that there are no open circuits. Insulation resistance testing verifies that the insulation is intact and that there are no short circuits. Voltage testing verifies that the correct voltage is present at the circuit breaker and at the load. Electrical testing should be performed by a qualified electrician using appropriate testing equipment. The results of the electrical test should be documented and kept with the electrical panel. Grounding is an essential safety measure that helps protect against electrical shock. The grounding system provides a low resistance path for fault current to flow back to the source, causing the circuit breaker to trip and energize the circuit. The grounding system consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor that connects the electrical system to the grounding electrode. The grounding conductor should be sized according to the NEC requirements. All electrical equipment and appliances should be properly grounded. Additionally, it is important to test the grounding system periodically to ensure that it is functioning properly. In some cases, it may be necessary to install additional grounding electrodes to improve the effectiveness of the grounding system. Surge protection is another important safety measure that can help protect electrical equipment and appliances from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other electrical disturbances. Surge protective devices, or SPDs, are designed to divert surge current away from sensitive electronic equipment. SPD are typically installed at the main electrical panel and at individual branch circuits. It is important to select SPD that are rated for the voltage and current levels of the electrical system. Additionally, SPD should be installed according to the manufacturer's instructions. Regular inspections and maintenance of electrical systems are essential for ensuring continued safety and reliability. Visual inspection should be performed to check for any signs of damage, such as cracked insulation, loose connections, or corroded terminals. Electrical testing should be performed periodically to identify potential problems before they become hazardous. Any identified issues should be addressed promptly to prevent electrical hazards and ensure the proper functioning of the electrical system. Maintenance tasks should include tightening connections, replacing damaged wiring, and cleaning electrical panels. Regular maintenance can help extend the life of electrical equipment and prevent costly repairs. When working on electrical systems, always follow safe work practices. To energize the circuit before working on any electrical components. Use lockout/tagout procedures to prevent the circuit from being accidentally re-energized while work is in progress. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Use insulated tools to prevent electrical shock. Work in a well-lit and dry environment. Avoid working alone, and always have someone nearby who can provide assistance in case of an emergency. If unsure about any aspect of the electrical work, consult a qualified electrician. Continuing education and training are essential for staying up to date on the latest electrical codes, technologies, and safety practices. The electrical industry is constantly evolving, and it is important to keep abreast of these changes to ensure that electrical work is performed safely and in compliance with current regulations. Attend seminars, workshops, and online courses to enhance knowledge and skills. Obtain certifications from recognized organizations to demonstrate competence in electrical work. Stay informed about changes to the NEC and other relevant standards. Share knowledge and experience with colleagues to promote a culture of safety and continuous improvement. By following these guidelines, you can safely and effectively install a larger wire on a 20 amp circuit and ensure the reliable operation of your electrical system.